All attendees are in listen-only mode.
Hello everyone, my name is Darla Saunders, and on behalf of the Atlantic Salmon Conservation Foundation and the Canadian Rivers Institute, I'd like to welcome you to today's webinar. This series is made possible in part thanks to the contributions of the Government of Canada. For today's webinar, we're very fortunate to be hosting Levi Cliche. Levi is the Clean Annapolis River Project's CARP's Executive Director, having taken the position in July of 2014. He's been involved with CARP since 1998 and has worked on a wide variety of projects including aquatic and riparian habitat restoration, agricultural stewardship projects, pollution prevention, and various ecological sampling and monitoring programs. After the presentation, we'll open the floor for questions and answers. You'll have the option of asking questions directly to Levi using your microphone, or you can type them in and Michelle will read them aloud. I'm now going to turn the webinar over to Levi.
Hello, as Darla said, my name is Levi Cliche. I'm with Clean Annapolis River Project, and the subject I was asked to present on today was Broken Brooks, which has been a program of Clean Annapolis River Projects for a number of years now. Over the years there's been many different partners involved, mainly NSLC Adopt a Stream. Anyway, what I plan to go through today is one, who we are as Clean Annapolis River Project, what we look at with aquatic connectivity, what its importance is, different ways in which culverts can act as barriers to fish passage. I'll go over the Broken Brooks program from its beginning, its development, and basically where it's going now. Look at briefly the data collection process, mostly by reviewing data sheets, and look at the type of data that we collect, the analysis that we apply to the data. Look at ways in which we prioritize culverts for restorations, and summarize some of the results of the program to date, and hopefully at the end of that leave a little bit of time for discussion and questions. To start off, the Clean Annapolis River Project is an NGO. We're established in 1990. We're actually about to celebrate 25 years on the 19th of this month. We're based in Annapolis Royal, Nova Scotia, and our mission is to enhance the ecological health of the Annapolis River watershed through science, leadership, and community engagement. So to that end, we take on a large variety of projects, some of which are environmental and ecological monitoring projects. We do a lot of community outreach and engagement at the moment, stakeholder engagement, environmental restoration, and various other pollution mitigation projects, etc. Here you can see a map of the Annapolis River watershed. Its borders very well defined in that map. The pale area in the center delineates the area. So if you can read the town names, you'll see that the headwaters up here begin around Aylesford, or east of Aylesford, in a bog area, and run downstream from, and are contributed to by the north and the south mountains on either side, run down through into the Annapolis Basin, and then exit into the Bay of Fundy. The watershed is quite large. It's 2,000 kilometers squared in size, about 100 kilometers in length between East Aylesford and Digby. It's the third largest watershed in Nova Scotia, and as I mentioned before, it's bordered by the North and the South Mountains, both of which have numerous tributaries that run down the face of the mountain, across the valley, and into the Annapolis River. The Annapolis River is actually one of the sites of the older European settlements in Nova Scotia, in North America. So it's quite well developed. There's a number of residential areas. It's covered in farmland. There's a great deal of forestry in the headwater areas. So what that translates to is quite a few roadways throughout the watershed. And due to the fact that we have many roadways and many tributaries, there's a lot of intersection between the two, which leads to a large number of crossings. Really, the focus of the Broken Brooks project is aquatic connectivity. So aquatic connectivity really is the connectivity of fish habitats in a watershed, or the access that fish have to various habitats within a watershed for various life stages. This diagram illustrates quite well that the placement of a barrier within a watershed has quite a bit of impact on the degree of fragmentation that can be caused by that barrier. We know that aquatic connectivity is quite important. Fish passage in aquatic ecosystem is essential for the survival of many species. Atlantic salmon are a prime example, where access to headwater areas to spawn is absolutely critical to the reproduction of the species. So, I mean, a barrier culvert or any other type of barrier low down in a sub-watershed pretty much prevents any reproduction of the species. We know that barrier culverts are leading to habitat fragmentation. We observed that quite a while ago in the Annapolis River watershed, but there are many studies that show that in other areas. Habitat fragmentation reduces access to favorable habitats for spawning, feeding, overwintering, and thermal refuge. I think, for example, for thermal refuge, in the summertime, the lower areas in the watershed are often quite warm, and fish need to escape to headwater areas in order to reach cooler water and avoid stress and potentially death. And barrier crossings can also isolate fish populations, so create pocket habitats essentially that are susceptible to disturbance, for example, siltation. So if fish are unable to migrate out of the habitats in which they exist to avoid events like that, then they'll be stressed or die. With a few examples here of how culverts can pose barriers to fish passage. Outflow drops, as seen here, are pretty much the poster child, very easily recognizable, easy to see why an outflow drop could be a barrier to fish passage. The one on the left being a fairly extreme example, the one on the right a little more subtle. What we know is that different fish species have differing abilities to jump, and so varying degrees of outflow drop will cause less or more of a problem depending on species and also size of the fish. I mean, Atlantic salmon are known for their jumping capability, but species like rainbow smelt don't tend to jump at all, so a very little outflow drop is able to prevent them from migrating up or downstream. Excessive water velocity is another issue that you run into fairly frequently. Culverts that are placed at an inappropriate slope aren't embedded in the channel or have a very smooth interior surface, often contribute to high velocities. And this is a problem because fish aren't able to sustain really high speeds that allow them to swim through the culverts and then make it across the other side. If there's no turbulence within the culvert, burst speeds that they're able to maintain for short periods of time aren't enough to get them through either. Incorrect sizing causes problems, whether a culvert's too small or too large. Culvert that's too small is unable to handle the flows of a watercourse, causing overtopping of the culvert, flooding, erosion, etc. The culvert that's too large basically displaces water over a large area, so you create basically an widened shallow reach in the river that fish aren't able to navigate. Again, inadequate depth, this is just a couple other examples, can be caused by reasons other than a culvert that's over wide, such as deterioration. Here are two examples. Deteriorating metal culverts often will develop holes, and the water will run down through and create a dry channel in the culvert itself while the water percolates underneath and around, basically making the culvert non-navigable. Deteriorating culverts also often cause physical barriers as they collapse and basically create physical blockages within the channel. Debris is a common concern and can come from many sources. Oftentimes we've noticed that culverts in wetland areas accumulate a lot of debris just because of the organic matter upstream. Large pieces of debris can wash from downstream or from upstream and get jammed against the inflow of a culvert and then start accumulating smaller debris and gradually sediments. Also, culverts make very attractive sites for beavers to build dams. They're nice narrow area. The dam's already partially built for them, so it's a good opportunity to reduce our amount of work and create a barrier. So over time, I mean, these accumulate sediment and smaller debris and then become extremely clogged, basically preventing any fish from getting through. With all the issues that are known about culverts and the fact that we understood that we had a lot of potential for issues in the Annapolis River watershed, CARP decided to do a little something about it, so we created the Broken Brooks project. So the project consists of, well, the assessment portion of the project consists of 5 parts. One very important step, especially in a large watershed, is to be able to identify all the culverts in the watershed so that you can look at the watershed holistically. Prioritize the culverts survey first, so decide which ones are actually a high priority and would actually contribute to better and more open fish habitat. Actually going out and taking measurements on the culvert, evaluating the barrier based on the data that you collect, and prioritizing barriers for remediation prior to conducting remediation planning. Over the years, a number of protocols were brought into the project. I'll go over that just a little bit later on some other slides. But there are four documents that were used. One by the British Columbia Ministry of Environment was the original one on the first Broken Brooks project. Some work that was done in Terra Nova National Park with Memorial University as well in 2009. Work that was done by the U.S. Department of Agriculture, Forest Service, and a document by Fisheries and Oceans Canada guidelines that they created. The first project that CARP undertook, called Broken Brooks, happened in 2007. So that was a result of a student project in 2006 that looked at road watercourse crossings in the Annapolis watershed. So it was a GIS project that looked at watercourse layers and looked at roadway layers, and took each intersection of a watercourse and a roadway and created a point. So each of those points were considered a potential barrier. So instead at that time, the only protocol that we had that were fully developed were the ones from BC Ministry of the Environment. So those were the ones that guided the work that we did that year. And prioritization was done based on some older studies that CARP had in office that looked at water quality over a number of tributaries to the Annapolis River watershed. Looked for some of the tributaries that had a good buffering capacity, basically contributing to decent pH, and also had good temperature regimes. So ones that had decent water quality for salmonids. And also systems that were known to have decent productivity from past electrofishing surveys, and also from anecdotal evidence from anglers. Here's a map of the Annapolis River watershed. So this is the one that was generated by Andrea Combs, who was in St. Mary's University. So these are all the road watercourse intersections in the Annapolis River watershed that were identified through that. As it says there were 1,615 potential barriers that were identified. So really, we had and still have a big job ahead of us to actually go out and assess and prioritize all of these culverts. And also keep in mind that these are intersections between fairly major watercourses and major roadways. I mentioned earlier that there's a lot of farmland and a lot of forest land within the watershed, and some of these roads are on private property, aren't necessarily going to be mapped roads, and some of the watercourses aren't mapped either. So there could be numerous more culverts than the ones that are represented here. The next phase of the program began in 2010. So what happened is that Hidden National Park were looking at applying protocol that was developed in Terra Nova, and what they wanted to do was assess aquatic connectivity within the park using what was called the Dendritic Connectivity Index, or DCI. And what that did was basically assess all the culverts within the watershed and use modeling software called fish crossing to model whether or not the barriers were passable to fish. And they used, I think, a 10-centimeter brook trout as the target. Basically then statistical analysis was performed using our software, and then the visual representation was generated using ArcGIS. It's a fairly complicated process, and it gave a decent product. It was very useful for a fairly small watershed, and what it gave them was prioritization of all the culverts within the watershed, and allowed them to identify which culverts they should be addressing to achieve maximum improvements in connectivity within the park. At the same time, partnership developed between KEGI, the Adopt a Stream program, Mersey Topiatic Research Institute, and CARP. There are other groups that got involved later on. And what happened at that time is that Adopt a Stream funded MTRI, and MTRI produced protocols with the idea that they could be used by community groups across Nova Scotia to start assessing culverts within their own watersheds, and can contribute that to a larger provincial base of knowledge. So the protocols that were developed by MTRI used a combination of all the protocols that I'd mentioned earlier, so those ones by BC Ministry of Environment, Terra Nova National Park, as mentioned, the U.S. Department of Agriculture, and Fisheries and Oceans Canada. And because at this time we were looking at the Dendritic Connectivity Index, and the idea was that the data from all the groups around the province would be analyzed by MTRI to give that as an output, culverts were prioritized based on position in the watershed. So the lower that a culvert was in the watershed, or the closer it was to the main body of water, the final destination, in essence, the higher priority it would be given for restoration, the higher priority it was given to be assessed in the first place. MTRI provided training to various community groups, including CARP, and also training protocols and technical support. And when all the assessments were done, essentially took the data in and attempted to analyze it to produce DCI outputs. At that time, too, CARP did quite a number of culvert assessments that year, and also integrated culvert restoration into the Broken Brooks project, where in the first iteration, all we had done were the analyses. In 2011, CARP wound up partnering with Adopt a Stream to revise the training program and then some of the protocols. So we stopped trying to use the DCI at that time. It was just a little bit too complicated to actually apply, especially to some of the larger watersheds, like the Annapolis River watershed. So that year, training was given to several community groups across the province. CARP provided technical support throughout the field season to the community groups that were collecting data, and also we created a reporting template. So try to create a consistent reporting template that all community groups would use, essentially that CARP would produce for them, so that all the culvert assessment data would be presented in a consistent way. At the same time, alternate methods of prioritizing culverts for restoration were developed that used a few basic considerations. I'll go over those a little later as well. In 2012 and 2013, some of the assessment protocols underwent some further refinements, so we're getting a little more experience with the program, and again, discussions with Adopt a Stream and some other organizations that were involved in an advisory committee. We decided to tweak it a little bit. CARP then also returned to a sub-watershed-based prioritization approach. We were finding, because of the size of the watershed, just assessing the ones that were lower in the watershed had us driving up and down 100-kilometer long watershed, not being really efficient. We were assessing a lot of culverts on mediocre fish habitat, so we decided at that time to start focusing in on sub-watersheds that we knew provided significant fish habitat. And also, at the time, we were combining culvert assessment or aquatic connectivity assessment with larger sub-watershed assessment protocols, where we're actually looking at various other management issues within sub-watersheds of the Annapolis River. CARP continued to deliver training, data analysis, and report writing until 2013 for community groups in partnership with Adopt a Stream as well. This past field season and going into this one, a few more changes were made. One of the things that CARP did, where we'd been spending several years assessing culverts and restoring some of them, and changing protocols, we found that we had a bunch of varying data sets that weren't really integrated and couldn't really be looked at holistically. So in the spring of 2014, these were smoothed out. One large spreadsheet was created, and the data was presented in a consistent fashion. So what we hope to be able to do with that is to like I say, look at all the culverts and analyze them holistically and try to prioritize culverts for restoration by looking at the entire data set rather than the data set from any given year, 1 year at a time. And then what happens is you lose track and leave some behind and don't look at the big picture. The Broken Brooks program, as of the end of this last field season, is going to be shifting primarily to restoration for the next year or two. Basically, we've got a large number of assessments, and we're going to be able to do some analysis on those. We'd really like to fix a lot of the problems before we move on and do more assessments. The data collection sheets for community groups were refined even further this year. That was in partnership with Adopt-A-Stream. And so Adopt-A-Stream now has a consistent format that's used by all community groups, and there's some more capacity that's been added to capture data on baffles. It also, because we've been working on a database or the creation of a database over time, the data sheet was created to allow a little bit more compatibility with that. Adopt-A-Stream also at the same time hired a coordinator to do the group training, the technical support over the field season, data analysis and reporting, so they've improved their capacity to provide that in-house. And as we speak, we're in the middle of developing the online database to house culvert data, culvert assessment data provincially. So we're still working that out, but we have a good field data sheet and a pretty good base to create a database. This, what I'm going to go over through the next pages are fragments or pieces of CARP's field assessment data sheet. I'm not going to get into the very specific techniques of how the assessments are undertaken. That's a whole other presentation in and of itself. This, if anyone's familiar with the Adopt-A-Stream template, is different in appearance and a little bit different in order, but identical in content. Essentially, we had a supplementary sheet for some of the baffle data, so that won't be present there for anyone, like I say, who's familiar. But just to go through it really quickly, take some general information about the culvert, the site, coordinates, and water quality data, etc. Get into some information about the culvert construction, so it's important to know, especially if you intend to in the future use modeling, some of the modeling software to assess the passability of the culvert. You need to look at the culvert shape, the material, and general construction. Whether or not it's embedded in the channel, whether there's beaver activity. It's important also to note whether or not you notice fish present at the site. Also, channel measurements are taken to get an idea of how the culvert is sized in relation to the natural channel. Then several physical measurements of the culvert are taken. So culvert diameter, height, etc. And also several measurements are taken with a survey rod and survey level to get an idea of various elevations throughout the reach and elevations on the culvert, to get an idea of what the slope of the culvert is, what the slope of the channel is, etc. Again, there's other habitat characteristics that are taken. This gives you an idea a bit about the habitat in which the culvert is placed. We've also found that it's quite useful in planning restorations from the office rather than having to go back to each culvert and collect all of this data afterward to complete a restoration design. So this is more information again about the downstream channel. This diagram, this is from the assessment protocol manual. It shows various points at which you place a survey rod to undertake a culvert survey. So it's a good reference document that should be carried in field when a person is doing culvert assessments. Just to give you an idea where the measurements are taken. Once we have the culvert data collected, we have to come up with an assessment criteria. So over time this changed. I mean, it went from very, very complex using the DCI protocols, and then I guess further protocols were developed in 2010, and these were altered over the years, and this is what we have now. Basically, if we're going to consider a culvert a non-barrier, it's going to have to meet the provincial guidelines in Nova Scotia, which are based on the DFO guidelines that were created. So a non-barrier culvert is considered a culvert that has absolutely no outflow drop and a slope that's under 5%. Anything outside of those criteria falls into a barrier culvert, which is then assessed as to whether or not it's a partial barrier or a full barrier. So a partial barrier has an outflow drop that's less than 2 body lengths of the target species or the target size for the species that you're looking at. In the case of broken brooks, we look at brook trout that are 5 centimeters in size. We're really trying to take a fairly critical assessment, so we use a very small target size. Also, the culvert slope has to fall between 0.5 and 2.5%. Anything greater than that becomes a full barrier. So an outflow drop greater than 2 body lengths of the target species or culvert slope over 2.5%. This is just a flow chart that shows the same information. It's another way to visualize it. So the next thing that we do, once we've decided whether it's a partial barrier or full barrier, and we have to do something about it, we have to assess what the options are for remediation. We haven't historically had a lot of options that were possible for us to implement. Adopt a Stream right now is looking at a number of different ways that restorations can take place. But our toolbox is basically what you see in front of us here. So for partial barriers, several criteria based on slope, whether or not there was debris present, and whether or not there were outflow drops, the size of the outflow drop, and the types of remediations that could take place. Primarily what we've done throughout the course of the Broken Brooks program has been debris removals and the installation of tailwater controls, basically weirs downstream of a culvert that raised the water level to accommodate for an outflow drop. And these criteria were taken from the BC Ministry of Environment document that was mentioned earlier. In order to prioritize culverts for restoration, a couple of criteria were looked at again. So we looked at the number of downstream barriers. So basically, how many barriers are downstream between the Annapolis Basin or the Bay of Fundy and the culvert itself. So anything with 0 barriers got a high score, 1 barrier, a bit lesser of a score, and greater than 2 barriers scored 0. In terms of upstream habitat gain, obviously the more upstream habitat that we're able to make accessible, the greater the point value that was assigned to that particular culvert in order to prioritize it. Whoops. You can see that the different scoring ranges were also assigned categories of high, medium, and low. Here's a table summarizing some of the results by year of the work that CARP's done, starting in 2007, with the number of culverts that were assessed, number of barriers that were determined, and what % of the culverts were determined to be barriers. You'll notice that while starting 2010, I guess, we really picked up some steam and assessed a lot of culverts, and it's been going down, I guess, gradually since. Part of the reason I should explain for that is that the assessment protocols in 2007 to 2011 allowed for what was called a preliminary assessment or a rapid assessment, which was visual and looked at a few different criteria, like whether or not there was an outflow drop present. I think it estimated slope and a couple of other things. We thought that really accounted more for the environment at the time, so it really didn't accurately represent what might have been going on at various other times and didn't really give you a hard number for slope and some of the other measurements. So in 2012 we started doing full assessments, so the detailed assessments that we went over just a little earlier on every single culvert that we did, and thus, I mean, it took a lot more time to do a culvert assessment. Also, in 2013, 2014, again, like I mentioned before, we started incorporating culvert assessments into a larger sub-watershed planning protocol. So there are other things happening on the side that took some focus away from the culvert assessments themselves. You'll also notice that as we got a little more critical with our culvert assessments, our surveys in field, it looks like the percent of culverts that were deemed to be barriers jumped. So I think, you know, our instinct may have been correct that the rapid assessments weren't really accounting for some of the barriers that were there. Again, to summarize the results, we've assessed 822 culverts over the 6 years of the program. 478 of those were identified as barriers, which accounts for 58% of the culverts that have been assessed. So again, if you look at this this watershed map and the road watercourse crossings that were identified in 2006, and visualize 60% or roughly 60% of those being barriers to fish passage, you can really see to what degree it's an issue in the area and how much of the watershed could potentially be fragmented. I wanted to show this slide. This is an output that we would include in our sub-watershed restoration plans or our reports. So this is a sub-watershed of the Annapolis River watershed. It's the Moose River watershed, and all the culverts within that were assessed. And this visually represents the barrier status of each of these culverts. So the red dots are full barriers. The yellowy orange squares are partial barriers, and the green ones are passable. So, well, I should also mention that the little purple dots are not fish habitat. You'll see that there are a lot of red dots, so see a lot of full barriers within the sub-watershed. So again, gives you an idea to what degree this is an issue. Also, I'm going to show you how good of a tool this is to identify where we need to go to assess or to remediate the issues that exist. The culvert assessments that we've undertaken have allowed us to address some of the issues in the watershed. So over the 5 years where we didn't do any restorations in 2007, we've done 54 fish passage remediations, and this has allowed us to improve habitat access to about 110 kilometers of fish habitat. And some of that's unaccounted for, so it should actually be a greater area. And we do that, as I mentioned before, through debris removal, such as you can see on the left picture within the slide, and also by constructing tailwater control weirs. So here's an example. So this rock structure downstream is installed to elevate the water level and bring the pool surface closer to what you can barely make out here as a low flow notch within this baffled culvert. So it brought the water level up roughly 20 centimeters and improved fish passage through this structure. Thank you very much. I guess we have some time. Hopefully I can take some questions and maybe I can answer them. If not, defer you to someone who can.
Excellent. Thank you, Levi. That was a really good overview of all of the work that CARP has undertaken. Thank you very much. So we will now open up our question and answer period. So to ask a question, you can use your webinar control panel, which is the little gray box you should be seeing in your upper right-hand corner of your computer screen. If the box is minimized, just hit the orange arrow and that will enlarge it. So there's two options. If you're using the audio of your computer and you have a microphone, you can figuratively raise your hand by pressing the yellow hand icon that has the green arrow on it, and Michelle will then unmute you and you can ask your question to Levi directly. Or you also have the option of simply typing in your question, and then that will be read aloud for you to Levi and he can answer.
Okay, we've already got a few that were posted during the presentation. So Rick Simpson from out in Kelowna, normally we get a weather update from Rick at the beginning of the webinar, but just so you know, Rick, it's very sunny out here on the East Coast today. Rick says, it's more of a comment than a question, he says, I'm so fed up with beavers liking our culverts. Do beaver deceivers actually work? And he would appreciate any experiences from the group.
I have no experience with beaver deceivers.
Maybe if someone on the webinar does, they could either raise their hand or type a comment in for Rick. Next we have Rebecca Herson-Peterson. She's actually from PEI. She says, are you aware of the stream crossing project that was undertaken by Ben Whalen from the Kennebecasis Watershed Restoration Committee? And if you are, what are the differences between this program and the one they developed?
I've been aware that they undertook a project. I haven't actually looked at theirs in detail, so I can't really discuss the differences between this one and that one.
I think I saw that Chris is one of the participants on today's webinar, so maybe if Chris from the Kennebecasis has any comments to that, please feel free to add them.
I don't think he's logged in right now, though.
Oh, he's not. Okay.
No. Okay, so I don't have any more yet. So if you want to type your questions or comments, please go for it.
Maybe I have a quick question for Levi, and this doesn't, I guess, directly relate to Clean Annapolis River Project, but Adopt a Stream's training program that they have now, what is the process for receiving training if a group wants to from them? Do you know?
I think contacting them directly, contacting either Amy West and Lauren LeBar. They should, I think, probably announce the training program early in the year. One of the traditional ways that they've announced the program has been at the annual gathering of Adopt a Stream affiliate groups, and that should, I don't know if that's been announced yet. It's happening in April often.
Yes, I haven't seen an announcement for it yet. So, right, it should be coming up pretty soon.
I think so, yeah.
Okay, I have a question from Jackie Bourgeois. She says, when on private lands, have you ever come across a culvert that needs complete replacement? How did you address this with the landowner?
What we've been doing, well, since we have so many culverts in the watershed, our first priority has actually been to assess culverts on public land, so on public right-of-ways. So at the moment, we haven't actually been doing assessments on private land. Yeah, can't really say that we've dealt with that situation yet. I should mention while we're discussing that too that that at the end of the year, when we've actually assessed all the culverts that we're going to assess for the year and then developed a report, we do submit that to NS Transportation Infrastructure Renewal to inform them of some of the issues that are on the lands that fall under their responsibility.
Maybe I can just add to that as well. I think Jackie may be on PEI, and I would just comment that I know that Central Queens branch of the PEI Wildlife Federation, I think they've addressed some culverts that need to be entirely removed on private land. So it might be worth getting in touch with Megan about that to see what their approach has been.
Okay, next we have Leanne Outhouse, who's actually with the Atlantic Salmon Conservation Foundation now. She says, how does the tidal power plant in the watershed impact restoration efforts for the watershed?
Really, I guess it changed our focus in terms of areas that we look at for Atlantic salmon habitat restoration, especially. But in general, I mean, it doesn't have an impact when we're looking at, say, brook trout. It's not a barrier to upstream migration. I guess the main consideration in terms of migration is mortalities on the way down through the causeway or through the tidal power generating station. So I don't know the context of the question, if there was anything specific you were looking for.
I'll get her to add more if she wants to add more. Chris Wild says, just I guess a comment back to Rick Simpson. He says, the nature of things had or has a great show on the success of beaver deceivers. So I don't know if that's something people can go online and find old Nature of Thing episodes. But Bruce Smith says, the last photo showed a variety of rock sizes in the check dams to raise the water level below the culverts. Were you concerned that the small rock sizes would blow out in the spring, or were there larger sized rocks in the structure which would be more resistant to washouts? Or were there larger sized rocks in the structure which would be more resistant to washouts?
Yeah, the rocks, or the average rock size that we used in the construction of that, were based on calculations of watershed area and slope. So we did use incipient diameter calculations to determine what size rock we should be using. So the vast majority of the ones in the structure would be resistant to being transported by the current. So.
Excellent. Ken Rawlings asks, how many total kilometers of fish habitat are there in the watershed?
I can't answer that, actually. A lot. No, that would not something we've analyzed yet.
Okay. Angela Douglas says, what has been your response from Nova Scotia TIR?
To be honest, not a great deal. We have a lot of enthusiasm at the management level. They want the information. In fact, they were actually partially funding the program over a couple of years when they were able to. But in terms of the local management, we haven't really heard a whole lot from them or seen a lot of action specifically driven by the reports that we've been submitting, unfortunately. Hopefully in time they'll start picking up on those, but they have their hands full as is.
Okay. I got an update from Rick on his weather. So he says it's 8 degrees and sunny but hazy. Unlimited visibility, and the lake is glassy. Wow. We're finally getting better weather out east, so it's okay. And Jackie Bourgeois updated her, so she just comments. She says, yes, she's on PI, and it's 90% privately owned. Next, Sarah Yakubowski, so she's with DFO. She said, I'm not positive if the CARP work would qualify for this, but I wanted the presenter to be aware of DFO's funding program, the Recreational Fisheries Conservation Partnerships Program.
We have an application in.
Well, good luck on that.
Thank you.
Rhonda Morrow says, if any culverts were government-placed, i.e. Department of Transportation, did they contribute any resources towards remediation?
Well, I mean, like I say, they did partially fund the project over a couple of the years, so yes.
Okay. Chris Wild asks, what type of cattle crossings and brook methods have proven successful or practical?
For cattle crossings, we did have some projects where we installed cattle crossings. I think for the most part, a lot of the farms in the area don't really do anything special for cattle crossings, but we have installed culverts with great care, I guess, in terms of sizing them and placing them properly, and those have been successful.
Okay. Next, just a second. Rebecca Peterson from PI just has a comment. Most of us have been doing this kind of assessment on our watersheds. I like the fact that you have this developed as a protocol, and I plan to implement. I also like the fact that you survey elevations and slopes as well as flow velocity. This gives us more to work with when approaching transportation departments. Kudos.
Thank you.
Diana Jenkins asks, how receptive have transportation been to trying to repair or install future culverts properly when property installation usually means more money up front, or I guess she means proper installments mean more money up front. She's thinking about provincial budgets.
Yeah, well, I mean, I think they're bound to actually at least attempt to install them properly. Otherwise, yeah, I can't. Might be better at answering that.
Leanne's following up on her. She made the comment about the Tidal station. She said she was just wondering if it had an impact on restoration efforts and/or the population of fish that are able to access the newly accessible areas.
Like I said, there's not much of an issue with them actually accessing the newly restored areas. It's more or less maybe whether they make it back out to sea. That's the question that's been brought up with some fish passage studies that were done in the past. And I think what happens, what's been noted, is that rather than use the fish passage provisions at the causeway on the downstream migration, because the power is generated on an outflowing tide, fish are sometimes drawn to the turbine. So.
I'm not sure I'm going to pronounce the name right, but Zolt Sari says, Are there new crossings being constructed in the watershed, and do you have the opportunity to do audits on the new crossings to assess if the problem is ongoing?
We're not contacted to do audits on new crossings that are being installed. One of the things that we intend to do going forward, it's been on the radar actually for a couple of years now, is to try to actually engage TIR a little more now that they've gotten a few reports from us, and try to get them to actually notify us as to whether they've actually repaired or replaced any of the culverts that we've flagged for them. So no, not at the moment, but it's something that we do have planned for the future.
Okay, excellent. Ken Rawlings asks if he can get a copy of your presentation. So Ken, what we normally do is we put a recording online on the Atlantic Salmon Conservation Foundation, and CRI will get it on a YouTube channel shortly. But if Levi's all right with it, we could put a PDF of the presentation.
I have no problem with that. No.
Okay, so we can, if he sends it, he'll send us a PDF of the presentation, and we can post that on the Salmon Conservation website as well. And then Angela Douglas says, if the area of issue is on private land, the work can be completed by the Watershed Group via the hiring of a contractor, given that the appropriate permits are in place. Our group has remedied issues on private lands, resetting hung culverts. So I guess that was more of a comment than a question.
Mm-hmm.
As an example, she's saying. Okay, I'm through what I see on my screen, so if anyone else has any more questions or comments, go ahead and madly type them in. And if anyone does have, well, I'll just say quickly, so Sarah Yakubowski, she's from DFO in Ontario, she had mentioned the recreational, I'm not going to get the full name now, but the DFO recreational funds available, recreational fisheries funds available. If people don't know about that, was it the last funding deadline for that program? Maybe Sarah can ask, because when I looked at it, I thought this was the last year for it, unless it gets extended. But I think that's been a pretty successful program in the last couple of years. All right, so I'll see if someone else has that. So Jackie Bourgeois also asks, is your assessment material available?
Yeah, probably the best way to go about it would be, again, to contact Adopt-A-Stream, so they would have the most up-to-date culvert assessment manual and resources.
Okay. She says, thanks. Lisa Pan says, the DFO fish passage guidelines have been revised as of February 2015 to accommodate the new NSC standards.
Great. Is that the last of the questions and comments, Michelle?
Well, Rick just makes another comment. Thank you for posting the PDF. I'd like to share the measles map graphic with the people working on the Kettle River Watershed Management Plan, who are also mapping watershed crossings for some long forgotten but turn-of-the-century logging and mining. Well, Rick, if you send that along, we can post that on the resource page as well if people are interested in seeing.
Great. Okay, well, a huge thank you to Levi. This presentation was absolutely excellent, and thank you to everyone who participated today. A reminder that the next presentation in this series is going to be on March 17th. Normand Bergerat from INRS will be presenting on the Water Temperature Monitoring Network. This will be a French version of an English presentation that's already taken place. But if you would like to take part, there is also going to be a bilingual question and answer session. So the presentation itself will be in French, but we'll have a question and answer in English and French. So a registration and a listing of all of our webinars is available on both the Atlantic Salmon Conservation Foundation and the Canadian Rivers Institute websites. So a big thank you to everyone, and we hope you'll join us again soon.